Effects and usage of admixtures. At the end of this lesson, you will be able to explain the effects of admixtures in concrete, explain the usage of admixtures. You are given a task to complete the repair work of an old public building located along the roadway. There are two constraints before you. One is to complete the task within the given time, and the other is to complete the work without affecting the traffic. Being a civil engineer, what will you do to complete the work on time? Yes, you will go for admixtures. By mixing admixtures to concrete, you can fasten up the work and at the same time obtain the desired strength. Since there are different types of admixtures, you would probably make use of accelerators, grouting agents, bonding admixtures, and polymer coating for the assigned task. Yes, these admixtures are suitable for localized patching works, gravity filling, and for sealing the cracks of the old building. It is true that different admixtures have different effects on concrete, and hence its usage is based on the work it is required for. In this lesson, we shall learn about the effects and usage of admixtures for obtaining desired results. When admixtures are added to the concrete mixture, it has a major effect on the properties of concrete like changes in workability, durability, strength, shrinkage, permeability, chemical resistance, and unit weight of concrete. Let us discuss each one in detail. Effect on workability. When we need a highly workable concrete, we add a plasticizer to the concrete mixture to make it more workable. These admixtures are absorbed by cement particles, which further create a repulsive force between the particles to overcome the attractive force. This improves the fluidity of concrete, thereby making it more workable without affecting the water-cement ratio. Effect on durability. Sufficiently cured concrete with a good amount of fly ash offers a dense structure with high resistivity to infiltration of deleterious substances. This addition of fly ash to the concrete increases its durability to a greater extent. The pozzolanic reactivity reduces the calcium hydroxide content, which results in the reduction of passivity to the steel reinforcement. Effect on strength. Admixtures like plasticizer, superplasticizer, fly ash, and ground granulated blast furnace slag are used for imparting higher strength to the concrete by increasing the cementitious content in the concrete. When the admixture is added beyond the actual dosage, the early strength of the concrete might be lower, but the 28 days compressive strength is comparatively higher, and the ultimate strength is significantly higher. Air entraining admixtures in concrete reduce the compressive strength of concrete. This reduction in strength is due to the voids created by the admixture. Effect on shrinkage. When ground granulated blast furnace slag and hydraulic slag are added to the concrete, they act as expansive agents and reduce shrinkage in the hardened concrete. Effect on segregation and bleeding. Segregation and bleeding in concrete are reduced greatly by air entrainment. The air bubbles in the concrete lift the aggregates and cement, which reduces the rate of sedimentation in the freshly placed concrete. Effect on permeability. Metakaolin and rice husk ash are used to decrease the permeability of concrete. Air entrainment in concrete has a significant effect on the permeability of concrete. Greater uniformity of concrete with entrained air is due to its increased workability and modified pore structure. Effect on chemical resistance. Calcium nitrite, sodium nitrite, sodium benzoate, and fluorosilicates are the corrosion-inhibiting admixtures used in reducing the corrosion of reinforcing steel in concrete. By adding fly ash to the concrete, we can prevent the sulfate attack to a greater extent. Effect on unit weight of concrete. Air entraining admixtures, when added to the concrete, decreases the solid material by 5% of its weight. Hence, The weight of this concrete is reduced by 5% of the weight of normal concrete. The origin of lightweight concrete is based on this concept. Finally, let us list the usage of admixtures in concrete. Usage of admixtures improves the workability of concrete during mixing, placing, and finishing process. It is possible to enhance the properties of concrete by adding an optimum amount of admixtures to the concrete. Addition of admixtures to concrete helps in faster constructions, and it is also economical. And it is best suited for repair and rehabilitation works. Summary: admixtures have a major effect on the properties of concrete, like changes in workability, durability, strength, shrinkage, permeability, chemical resistance, and unit weight of concrete. Usage of admixtures improves the workability of concrete during mixing, placing, and finishing process.